Hello there, our wonderful and esteemed viewers on this favorite mathematics YouTube channel, Mathematics by Abu Zainab. That channel specially created for you and I to demystify mathematics and tackle the age-long phobia associated with this all-important subject, one topic at a time. So this class promises to be very interesting, exciting, and most importantly, fun, as usual. In mathematics, as we know, particularly in algebra, most concepts such as factorization, expansion, and what have you are more or less reverse processes, meaning that you can carry out an operation in a forward manner and it's possible to reverse the process. If you expand an algebraic expression, it's very possible to factorize the resulting answer to get the original question. This is what I mean by reverse process. In similar fashion, when you have algebraic fractions, that is fractions that have algebra in them, it's possible to simplify by adding and subtracting to get an answer. So the essence for today's lesson is how to resolve the gotten rational function back into the components. And this is the stuff of partial fractions. Let's move in. Recall that we have to simplify, say 2 over x plus 1 plus 1 over x minus 2. This is elementary algebra. So all you need to do here is to work with the LCM of the denominators, which in this case are x plus 1, x minus 2. So x plus 1, we tackled x plus 1, we are left with x minus 2. So we have 2 bracket x minus 2 plus 1, then x plus 1. So expanding the numerator, we're going to have 2x minus 4 plus x plus 1 over x plus 1, x minus 2. You need not expand the denominator. So now, simplifying further, the numerator gives us 2x plus 1x is 3x, minus 4 plus 1 is minus 3. Then over x plus 1, x minus 2. And that is the simplification of this simple algebraic fraction, which is the forward process. The reverse process now is to take this particular answer back to the component fractions. And that exactly is the essence of partial fractions. So let's delve in. There are some rules as to partial fraction. The basic of them is that the numerator must be of a lesser degree than the denominator. That's step one. Then most of the concepts we are going to review here has to do with the denominator. As a matter of fact, all of them. The denominator determines what we do in partial fraction. And there are 4 cases we are going to look at in this topic. And today we are focusing on case 1, which is when you have distinct denominators as factors or distinct factors as denominators. What do I mean? Let's delve in. So I call this case 1. Distinct factors as denominators. So how do we resolve this? With 2 examples, let's resolve into partial fraction components. So we have question 1 there. We have 4x plus 5 over x plus 2, then x minus 1. So the question can come in such a way that the respective factors are already given. You don't need to do anything. Or we have case 2, we have x plus 5 over x squared plus 2x minus 3. So you can't be given question in this format. It's either you're given the factors already or you're given the full quadratic, whereby you have to factorize. Now, let's solve. How do we resolve into partial fraction? We have how many denominators here? We have two denominators. That means we're going to have two letters, say A over the first denominator plus B over the second denominator. If there were three, that would be C over the third denominator. So in this case, we just have to simplify this as LCM, of course, x plus 2, x minus 1, and that gives us A, x minus 1 plus B, x plus 2, which is equals to 4x plus 5 over x plus 2, x minus 1. If you look at both sides of the equation, we can see that denominators are equal. So we can actually equate them and just say the numerator 4x plus 5 is equivalent to the numerator on the other side, x minus 1, that be x plus 2. Now, there are two approaches to solving it from this point. We can use what is called the cover-up method, or we use what is called comparing coefficients. But the easier one I'm going to explain for this video is cover-up. We are going to look at the other method in subsequent videos. Now, cover-up method basically means at a point in time, we are going to nullify each of these brackets. So to make the entire A or this bracket to become 0, we use the additive inverse of minus 1, which is plus 1. So I'm going to say, let x be 1. So once x is 1, so I'm going to affix 1 into all the values of x. I'm going to have 4 times 1 plus 5 is equal to A, 1 minus 1 plus B, 1 plus 2. So 4 times 1 is 4 plus 5, 9. 1 minus 1 is 0 times A, still 0. 1 plus 2 is 3 times B, 3B. Therefore, B is 3. We've gotten B as 3. So similarly, we say let x. So to nullify B, we use the additive inverse of plus 2, which is minus 2 here. So that means we're going to substitute minus 2 all across. We have 4 bracket minus 2 plus 5 equals A. So we have minus 2 minus 1. That's minus 3. That's minus 2 minus 1. Then if we put minus 2 plus 2, that's going to be 0 times B is 0 as well. So 4 times minus 2 is minus 8 plus 5. Minus 2 minus 1 is minus 3A. So minus 8 plus 5 is minus 3 equals minus 3A. Therefore, A is 1. So we've gotten our A and B. We then go to conclude from here that 4x plus 5 over x plus 2, x minus 1 is equal to, just using this, A is 1. 1 over x plus 2 plus B is 3. That's 3 over x minus 1. And that is the solution. So we have been able to break down this partial fraction into the constituent components. In other words, if we were to simplify this particular sum, we definitely get this as our answer. So that is what is meant by reverse process. And that has been the first example, which I believe you found quite straightforward and very, very easy. Without wasting much time, let's go to example number 2. Now, pretty much the same way we have here x plus 5 over x squared plus 2x minus 3. The only difference in question 2 is that we do the job of figuring out the factors of this quadratic expression here. And that's not an issue because we treated this over and over in our last series, the quadratic series. If you have any issue whatsoever with that, you can please visit our website, our channel rather, and look at the video on factorization method of quadratic equations. So here is simply, when you factorize this, you're going to have x plus 3 and then x minus 1. Those will be the factors of x squared plus 2x minus 3, which is now simplified as, because we have two distinct factors, don't forget we are under the heading distinct factors. So we can choose to use any letters, p over x plus 3, then q over x minus 1. And go ahead as before. The LCM here is x plus 3, x minus 1. So when you take the LCM there, we're going to have p x minus 1, q x plus 3. And there again, we can compare both sides. We are going to see that denominators are the same. So simply compare the numerators. Hence, x plus 5 is equivalent to p x minus 1 plus q x plus 3. So at this juncture again, we need to nullify each bracket one at a time. To make this bracket 0, we use the additive inverse, which is plus 1. So we set x equals to plus 1. And if that is done, I'm going to have here 1 plus 5 is equals to 1 minus 1 is 0 times p is 0. Then 1 plus 3 is 4. We're going to have q 1 plus 3. Hence, we have 1 plus 5, 6, equals to 4. So q then will be 6 over 4, which is 3 over 2. So in a similar vein, to make x plus 3, the bracket to be 0, we use the inverse of plus 3, which is minus 1 in this case. So we let x equals, minus 3 is the inverse of plus 3. So we have here, to slot that minus 3 all through in that equation, we have minus 3 plus 5 equals, so here we have p minus 3 minus 1. Hence we have 2 equals to minus 4p. Then p is equals to minus 2 over 4, which in turn is minus 1 over 2. So we've gotten our p and q. Hence, we simply go back to the very first statement here, that x plus 5 over x plus 3, x minus 1 is equals to, what's p? Minus 1 over 2 all over x plus 3. Then plus, what is q? 3 over 2 all over x minus 1. If you notice this particular example, we've got fractions. So there's a way we write the fractions. Interestingly, we have the same denominator for the fraction. So we can simply say minus 1 over 2 x plus 3 plus 3 over 2 as well. So the denominator of the fraction has been brought down here. Minus 1 over 2, then 3 over 2. And that again is the end of the solution to this particular problem, which I think you find quite straightforward and interesting. If you do, please feel free to, as usual, subscribe, like, share, and most importantly, turn on your notification button so that you'll be the first to know when our next video drops. So in summary, what we have looked at today is partial fraction, how to resolve the rational function in algebra into the components. And I said that the basic determinant of what to do is the denominator. And the essence of today's lecture is to look at the case 1, where we have distinct factors as denominators. And to do that, we follow these simple procedures. And that has been it. Thank you, and stay blessed.